Hello everyone, I am Ibrahim Sheikh, MSc Computer Science student from SIS College of Arts, Science and Commerce, Mumbai. Currently I am an intern at Emerti Information Technology, Bangalore. So the final project for this internship is a car black box. So what does a car black box means, we are going to see in this video. So let's proceed ahead. So the topics which we are going to discuss in this video is like what is an embedded system, introduction and its purpose, learning outcome during this internship, description of the project, functional requirement, working, interfacing, application, conclusion, project demo. So let's move ahead and see what is an embedded system. So it's basically any combination of hardware and software which is intended to do a specific task. For example, we have lot many appliances in a home. So the example goes like a microwave, TV, washing machine, car black box, which is my final year project. So the introduction for this internship goes like it's an online embedded system internship at Emerti, Bangalore. So this internship is totally based on Pixing lab board, which is nothing but a simulated version where we have different microcontroller. So in this internship we have chosen PIC16 F877A, and the codes which we are running is on MPLab XID version 5.3. So I completed my final year project of this internship under the mentorship of Rajini Shinde. So the purpose to develop a car black box is it records the event going on the car along with the time and the speed of the car. User can log in through password and view the log or event. Also he or she can clear the log according to the user requirement. User can log in only through the right password and can also change the password. User get 3 attempts to enter a right password. If he fails to enter a right password, the user gets blocked for around 60 seconds. We have given a specific time of 60 seconds. We can exceed the time like 15 minutes, but as of now we have used only 60 seconds. So the learning outcome during this internship was introduction to embedded C. So the embedded C was taught us from the scratch, like the condition, loops and operators, arrays and pointers, functions and strings, storage classes, processor directory and many more. Introduction to embedded system and microcontroller, MPLab XID, XC8, PiximLab. Introduction to various peripherals of PIC16F77A, which is nothing but the microcontroller which we have used in this project. Interfacing various peripherals of that PIC16F77A. So the functional requirement for this internship which we have used for developing this car black box is we need a Windows OS, Dev C++ for setting up the environment for running a C program, MPLab XID version 5.3, XC8 version 2.10, PiximLab board. In this internship we didn't use a physical microcontroller, but what we have done is use the simulated version of that microcontroller, which is almost same like a physical board. So the working of the car black box is when the car black box is in on state, the CLCD displays the event on, which is followed by the current time and the speed. As you can see in this diagram, we have a time, event and speed. So on pressing key 4 or 5, the matrix keypad or switch 4 or 5, enter password screen is displayed. So on the matrix keypad, when you press on the key 4 and 5, a screen will display to enter a password for the user login. After entering the current password, 3 options will display on the screen: view log, clear log and change password. There are total 3 attempts assigned to the user to enter the correct password. As I have told you before, that the user get only 3 attempts to enter the correct password. If the user enter the wrong password, it gets blocked for 60 seconds. Switch 4 and 5 is also used as an up and down key. So in the matrix keypad, the switch 4 and 5 is functioned in such a way that it can also be used as an up and down key to control your CLCD screen and select the correct option. The view log records the event going on the car black box. There are total 8 events including the on, C, gear neutral, gear reverse, gear 1, 2, 3 and gear 4, which are nothing but a car gear changing events. Along with the event time, it also record the along with the event time is also recorded using RTC, and also the speed of the car with the potentiometer P1 ANO. The clear log clear the recorded logs. Change password will change the password of the controller. All these options are selected with the star next to the option by pressing switch 6. So this is a screenshot of a Pixim lab which we have used in our internship. So this is the CLCD, this is the switch 1, 2, 3, 4 and 5 and 6. These are the switches which we have used to control and change the event on the CLCD. This is the potentiometer which will vary the speed of the car. These are the LEDs. This is the RTC with the help of which the real time is created. The MPLab screenshot of an MPLab XID which we have used for the coding purpose. This is the Pixim lab architecture where this is the PIC16 F877A which we have used. These are the various components of it. Some of it are GPIO pins, buzzer, digital keypad, SSD, matrix keypad, CLCD, analog to digital converter, LEDs. So the features goes like PIC16 F877A operating frequency of it operates in a frequency of DC 20 MHz. It has 5 input outputs, ports, 15 interrupt, 3 timers which are nothing but a timer 1, 2, 3, flash memories, data memory. The component which we have used in this project are the timer, CLCD, analog to digital converter, I2C, digital keypad, DS1307. So let's see what does a digital keypad mean. It is an input device which is used for a user to enter the input and process by the microcontroller. In this project, it is used as a switches to enter the password and do the control by up and down keys. So this is the okay. So this is a diagrammatical representation of the matrix keypad. So let's move on the another component, CLCD display, which is nothing but the most commonly used to display the ASCII characters. Flat panels display which uses liquid crystal in its primary form of operation. Supported communication model are 4-bit and 8-bit model. So the model which is supported for the communication purpose in this CLCD display is a 4-bit and an 8-bit model. It is long lasting and the energy which is consumed by this CLCD is not that much. Analog to digital converter, ADC. Analog to digital converter converts and translates analog electrical signal for data processing purpose. An ADC convert an analog input such as what we use a microphone which collect sound and convert it into a digital signal. Timer. A timer is a specialized type of clock which is used to measure time intervals. It maintains the timing of operation in sync with a system clock or external clock. used to count cycle and perform a particulation to specified movement or optionally start and interrupt cycle. The PIC16 F77A basically has three timer modules: timer 1, timer 2 and timer 3. The application for this car black box is car rental company uses it for tracking the record on the vehicle. The customer, when whatever the event is going on the car, is get recorded by the car black box, which is used by the car rental company to track the customer. Conclusion for the car black box is car black box technology required to learn and understand. Car black box will update according to the technology and most likely candidate for the future production. Scale application will take full advantage of the unique characteristic of this car black box. So the project demo is like this. So this is the coding for our final project. This is the coding part where our main C file is this. It's almost 400 plus line of coding, and this is the header file .h file. So let's load our hex file. So this once the hex file load, the CLCD displays the time, event and the speed. So this is a switch 1, 2, 3, 4, 5 and 6. So we use switch 1 for changing the event. So let's see. So here the event gets changed to C. Let's again change with the switch 2. Okay, gear N. So let's change the speed also. As you can see, the speed is varying. So let's set it like 87 and change the gear to gear reverse. Gear 1, 2, 3 and 4. And that's all. No more gears. So to go back, we have to choose switch 3. Okay, gear 3, gear 2. So these are the event which has been recorded in our EEPROM. So to log in into our account, we have to click on switch 5 or 4, any of the key, to enter the password. So let's enter a password. For this project, the password is 2, 4, 2 and 4. So this is the screen. There are three options available: view log, clear log, change password. So let's view a log by clicking on switch 6 with the star next to a view log. So these are the log event which has been recorded: gear 3, C, GN, GR, G1. That's all. These are the events which has been recorded. So let's reset and again enter our password and clear our logs. So for this, use this down key and select it clear log. So the logs are successfully clear. There are no more log. To verify it, let's view a log again. So no logs has been found. So let's enter a wrong password and see if a user gets blocked or not. So 2, 2, 4 and 4. So wrong password, 2 attempts remaining. So we have only 2 attempts to enter the correct password: 4, 4, 2 and 2. Okay, wrong password and 1 attempt remains. 2, 2, 2 and 4. Okay, the user gets blocked and the user have to wait for 60 seconds. You can also change the time according to the user need. For this project we have chosen only 60 seconds because it was very time consuming. So yeah, that's all the working of our car black box. The log. So this is all about the final project which we have done in this 1 month internship at Imerti. So thank you so much Imerti for giving me such an opportunity to build my career in embedded system and giving us a great learning experience throughout this internship. Thank you so much Imerti. Thank you.